Hello, Professor. Beck Cole here with
Sam Davidson, also here. And today, as you can see on our PowerPoint slide, or keynote slide, we're going to be talking about some beavers today.
the
Hundreds of beavers to be exact.
and the statistics behind water sources and how they affect beaver dams.
Yeah. So I guess let's get into it.
Let's get into it.
Mm-hmm.
Alright, now for our introduction. Cinnamons, preface, debut, opening, inauguration.
They sound just like an introduction.
Yes. So, our topic, why we chose the overall size of beaver dams, is dependent on the water source used by beavers. That sparked our interest, specifically mine, because of a recent film I've watched, Hundreds of Beavers, where, I'm not even joking, hundreds of beavers, hundreds, build a dam, and it breaks, forming into the Green Bay River. And I was curious if the water had an effect on the decay of the dam. Who knows, maybe it did. So our original hypothesis, with the increased number of beavers, X, the structure of the dam, Y, will become stronger and more fortified.
And that changed into the hypothesis we have now. When a multitude of dams, water sources, both spring-fed and stream-fed, the longer the average dam length will be. Why? Now, when it comes to methods,
Yeah, we f***ed up.
yeah. So when we started researching for this, again, we mentioned the original hypothesis. We couldn't find jack squat. And then it came to the second one, and we were looking through Google Scholar. We were looking through all these sources for a good while. And all we found was a box plot. Yep.
A single box plot.
A single box plot. And you can see right there all the data. Very, very clear. 4 items out of 300 on that y-axis. So
Beavers.
there's a lot of questions here. Like, okay, if you only have this data, then why are we even doing this, right?
4th grade.
4th grade. But also, there are 4 interesting data points that were within that article.
There were.
No, there were. This article. www.sciencestory.com. God bless it. 162 beaver ponds were surveyed over 19 sites in the summer of 2019. The number of dams observed at each site ranged from 2 to 19, with an average of 8 dams. Now, I don't know about you, being the math nerd I am, 19 and 8 equaling 152, 162, it's kind of close. It's close. The longest and shortest recorded dam lengths were 1 meter and 295 meters, and mean dam lengths ranged from 4 to 116 meters per site. Now, Becca, let me ask you a question. With this range of mean dam lengths, does the article at all specify the actual mean dam length of each site? No. I mean, unless we were blind.
Why?
You are blind. But it's just 4 to 116. So, for the sake of sanity, we added 4 and 116 and divided it by 2. It equals 60. That's our mean. So let's just take out spring-fed, stream-fed, get those out of here. There's no real need for them. We just need...
It's useless.
It's useless. We just need the both. Where does that leave our independent and dependent variables? Good question. We're gonna skip past that.
It leaves them drowning.
Yes, but we're gonna skip past that for now. So, I did manage. But this part was me. You must admit. Okay. French. Gathered 162 numbers together and averaged it out to that mean of 60 that I mentioned earlier. And,
Yeah.
So 41 was the best bet, and,
Or so we thought.
so we thought, but there the rest of it goes. Averages out to 60. It's got those outliers there. Again, the one at the top, 295 meters, as was mentioned earlier. Yeah.
Are the assumptions for linear regression satisfied? No.
So the residual plot gave us a chart.
Nice looking chart.
Yeah. And again, with all of this approximation, I can't trust any of this to be completely accurate.
Can't trust it.
But I can trust that our percent value here is below 0.05, so there's that, I guess.
Yeah. So our regression slope and linear equation, y equals 1 point. Yeah, it's the same. It's the same equation as the figure line graph.
Yeah.
Same one.
Well, I mean, yeah, exactly.
Same damn equation.
And then
Our correlation coefficient, a multiple of r was 0.9238768.
I mean, an odd name for it, but I mean, it makes sense. It was hard to find, but when we
did find it.
We did find it. We squared, or got the square root of our good friend here,
Our coefficient. Of
r
determination.
squared coefficient of determination, and it was accurate.
We
So
were determined to find that determination.
ooh, that's good.
Yeah. That's like just like the grades we're getting.
Yeah.
Yeah, so our prediction for the dependent variable, y equals 1.505x minus 25.619. 162 ponds were, what's the word I'm looking for? Not discovered, found.
Yeah, they were cited. And
Yeah.
again, the only way to find the dependent variable here is like, well, where's the 163rd? So, for presentation's sake, to find the x, the y would be 1.5.
Yes,
Now, some interesting features of this data.
very interesting.
This is so approximate that like it was hard to even get a few numbers. But in trying to get a decent approximation, we got these facts from this.
Nice going, Sam.
Okay, and then there's our fitted line plot as well. I mean, there's interesting stuff in there, but none of it's concrete.
Yeah, it's very interesting.
It is interesting because it's like, yeah, it's both. I just wish there was more, but with the approximation, it was interesting to kind of see where the data could have potentially landed.
Exactly.
So, yeah.
Alright, so for our application, do you think there are other methods you could have used to come to a different conclusion about the correlation of your data? Nope. Second part of the question is, could you have taken a biased sample, for example? Like what, building our own dam? Are you out of your damn mind? Next question, what additional independent variables would you choose to better explain the variation of your dependent variable, if any? That's a great question.
Oh!
What?
You said out of your damn mind, like, because we're talking about dams. And you're like, hey, what? Are you out of your damn mind?
Read the damn question!
I think we lost our damn minds. So, we're back on track here. What additional independent variables would you choose to better explain the variation in your dependent variable, if any? No, I don't know. With this scenario specifically, just with beavers and the fact that I feel like from what we've learned, it's hard to garner statistics, find statistics on them. Just no. No. Can any of your results be used in decision making? I'm going to do a little callback here. Yeah, that's a good question. No. Because it's approximate. It's like, if like this wouldn't fully benefit. There are people who have studied this and was Wish we had all the data still, but is what it is. We did the best we could with it.
Yeah, we tried.
Indeed.
That's all that matters.
Is it? So, I guess in conclusion of this wild journey,
Oh, the witches.
yeah, maybe we just shouldn't mess with dams.
Yeah, don't mess with it. Especially that freshwater dam.
Yeah.
Those dams.
Because you can't get the statistics that you want to get on them.
Yep.
Finn.
Ben. Ben! What do you mean, Ben? It's tail!
Damn mine.
Read the damn question!
I think we lost our damn minds.
Okay, reset. Alright, now just read the question. You're gonna read it this time.
So,
Read
can
the
any...
question. You gotta read the question. What additional?
You answered it.
Alright.
Okay.
You said
Okay, fair.
Alright, reset.
Yeah.